All right. Sorry, bumping the microphone there. Welcome back to another week of Haskell hacking. We're gonna continue working on asteroids tonight. So we got rotation working last week, and today I guess. Oh, and we got thrust working, which is good. So yeah, now we're gonna get like the ship moving around a little bit. Oh, no, double dash there. What have I done? Dash, double dash. There we go. Okay, get the project building, get the source code going, that sort of thing. Oh, we were looking a bit at button state handling, I think, last week. Maybe like doing some like refactoring around this or something. That's right. Then we got all the button states going. I just kind of wanted to see if there was a way we could compress this down a little bit. It's not too bad, really. Let's just make sure. Let's you know, run the game so you can see what's going on. I'm not in the right directory for that. Cool. Okay, there we go. Yeah, so there's our asteroids window, right? There's our ship rotating around an axis. Alright, and then we're going to, and we got thrust, but I don't have an indicator for that yet. But it works. So it looks like the keys are kind of working. Okay, let's take a minute, see if we can't do something with this here. So the thing is, we're just it's kind of looking at me and staring me in the face like this could be compressed here, because we got Q press event, QA press event, right? And we're passing in the event. We're building a function here as keyboard key with just slightly different parameters. All right, say A down and A up, or A press and A up, right? We're just saying pressed, released. In fact, we could probably even make this a little bit more consistent. Change this to release. Events. So the difference is only really that there's like a press and a release, but it's for the same key, and it just changes the state of the key. Which is our button state record type here, which could be a map, but we make it I made it a record here. That's kind of my first instinct. Because if we add another button in there, we're going to get twice as many lines. We're going to have to basically add a couple more lines for each case here. It would be nice if there was a way to do this. So, press and release. Two functions. Slightly different parameters for each. We get the state based on if any of these events are true. And then we change the state of our game button state depending on which one is press this frame. Otherwise we leave it alone. And then we have the next button state. Which we pass in here when we go to update. Almost feel like maybe we might be able to put these related concepts together into a data structure. Something like that. Key pressed, key released. And then I'm thinking if we put these in here, then we can evaluate this structure against an event and just get a button map back. Another button state. Maybe call it like get key press, and takes a key press, an event, an SDL event. Maybe if I flip those around, actually, might be better. Yeah, I should have the arrows in place there, but yeah, if we do like this, and then if button state had a way to, if there's a monoidal instance for it, that'd be pretty neat. But what would that even be? And how would that even... Would it be a proper monoid? Because then you'd be able to do... If there... Assuming there is one, what I'm thinking is that we could just have... just put some pseudocode here. We would have, like, let button state equal to... And then we can, like, get key press... I guess Gatekeeper is going to have to know about all the SDL events that we've pulled. Events. And then we can define all our key presses, so it could be like quit pressed. And yeah, it wouldn't be SDL event, it would be the list of SDL events. This would be fine. Anyways, it would kind of look like that, I think. SDL events, and then we can just combine them together. Down is pressed. So on and so forth, kind of like this. So we can lift all these out into their own their key press definitions, and then we can just combine the button state together like that by individually checking each one and then combining the result. This might not work. The reason why it might not is like this. Let's go over to a REPL. That seems like a good idea. So bool has these instances defined: equal, ord, enum, show, read, bounded. No monoid or bool. You can't combine true and false. It needs semigroup. Sorry for that. There's no semigroup for that. There's no monoid either. Sorry, semigroup's the other thing I'm thinking of. There's no semigroup for that because it doesn't really make sense. All right. You could say maybe it's like true and true. If you wanted to combine two Boolean values together. But they don't have a semigroup instance to combine those together. So we could define our own type that has a semigroup instance, and combine those together so that we could do this. And then the button state semigroup instance would be trivial because it would just use the instances of all its fields just fine. Or we could have our own combination rules. Why doesn't it have a semigroup instance? There's a good reason for it. I just can't think of it off the top of my head. Haskell Boolean semigroup. Associativity might be the reason why, maybe? And also, like, defining what this means for Booleans. So is conjunction associative as the question, right? Conjunctions are so we could maybe write our own semigroup instance for something like our own type. Maybe not for bool, but we do key state. Key held, key down, key release. And instance of semigroup for key states. Right, where key down and key down key down. And this is almost looks like our table from last week. All right, key release. Right, and mirrors our logic down below that we're kind of doing here. All right, so if the button state for W is pressed and the game button state it's not up, then true, it's pressed. Alright, if we have the W key up event and the button state is already up, then the up button state is false. Otherwise, we just leave it the same. So if we have a key down and we're combining it with a key release key state, then it now becomes key down. And if we have a key release key state and we're combining that with a key down, then we have a key release. I think that makes sense. Yeah, I can't have those wildcards hanging around. Let's comment this out for a second. And this. Okay, cool. So, key down, key up, release. Okay. Now the property we need to satisfy for this to be a proper semi-ring. What's the value of this? It says it's key down. Okay, let's do it exactly like that. But all right, so we got the A, B, and C. It should be the same as the other way around. Right? So key down was for A. And then we have key release for B. With key release for C. Is it the same? Technically, at least in this one example, it is. It's not proof that it's actually a form of a proper semi-ring here. It's all right. At least that example kind of works. There's like a quick check library for testing these properties, these laws for us. Our class laws. Quick check classes. Let's see. So we could build a quick check test for this, just to verify that this property is true for our type. Just for the sake of the stream, I'll do that if it becomes a problem for the game and the key buttons stop working when we do this transformation. Or, you know what, it's actually, let's just do it. It's not that big a deal. I kind of want to get to the thrust and movement code before the end of the stream tonight, but I think this will be fast, so let's just do that. So we go package, we're gonna add quick check, just need it for the asteroid test. And then we need quick check dash classes. Cool. So let's open up our test file. So we're going to import test talk quick check, is it? I forget what it is. Oh my god. And quick check classes. Test talk quick check classes. Okay. Import test talk quick check classes. And hang on. We're gonna need HSpec. This will be HSpec. Describe key press, key state, right? Meh. Key state. And HSpec has quick check integration built in the box, I believe. We can define it like this. Semi-ring, so semi-group. And how do we use these? Laws check. Monoid laws, and then we proxy ordering. Exponential, rectangular, semi-ring, ring. Storable, generic. Semi-group laws. Okay, and it returns a laws and takes a proxy around my type. And I gotta run the laws some in thing, or is it just fine if I return it? check one. No. I'm not sure. I don't recognize this. I'm not sure if this is the library I've used before, but we need some kind of proxy to pass it our type. Okay. Alright, so we import data.proxy. Proxy of key state. Not sure. Not sure what I'm doing here. But we'll find out. Okay, HSpec needed. Probably just typed it in the package wrong there. That's easy. Get some water. Check on chat. How you doing, chat? We're good. Doof. Well, that's running. Let's look back at this stuff here. So we have, assuming that's all good, we have this thing key state. So now we can collect these together to construct a button state. If we change the type here of bool to key state. I'm gonna change this over to record syntax. Yeah, button state left, key release, and button state right. It's on for some reason. It always takes a while to compile. It's a good library though, for the most part. I like it. Use it a lot. Got all your JSON needs. Right, so init button state, blah blah blah. So the logic if we can pull this up and out. Alright, in order to get this code here. Quick pressed. Ah, it didn't work. Okay, there we go. Keep the test running while we do this. Okay. So import. And so many errors here. What happened here? All right, because I changed the type of everything. So let's undo that for a moment so we can focus on the tests. Getting that working. Back to bool with you. Change that to false. Yeah, we should get back. Here we good to go. Props not in scope. I probably meant to import that. All right, we need an arbitrary key state. Let's define it as an orphan instance here. That just means like when you define an instance for a type, you have to put it in the same module, generally. If you put the instance definition in a module different from the type, then you'll get this, what's called an orphan instance. Not a huge, can be a bit of a thing sometimes. I generally actually try to avoid my orphan instances as much as possible. So I don't know, I'm on the fence about this, but sometimes I put the quick check arbitrary instances in my module with my types, which means your main code has then a dependency on quick check. Sometimes I like to do it this way, and just put no orphans warnings, or just disable the orphans warnings on this module, on the test modules. I'm not sure how I feel about which and when. So I'm just going to do it this way tonight, because why not? So we have to define this one function called arbitrary that picks, it's going to basically pick one of our types. So quick check has a combinator, I think called one of, if I'm not mistaken, or we can either give it key down or key release. Two values here, and it'll pick one of them arbitrarily. I'm at one of, not capitalized. Gen key state. Okay, yeah. So the expects generators, so we'll just go to use pure. Okay. So laws doesn't have a testable instance arising from prop. Okay. So do a loss. Let's in IO. Maybe I should be using a different library. I don't want to run them in GHC, I want to run them in my test suite here. Package checkers. Turns a test a batch. I could probably just run them in IO. Check, was it check one? Laws check. Laws check like this. So I'm running IO actions inside a test. Seems okay. It seems like it is probably a semigroup, so we're good. So that's how you do that, I guess. Cool. So next part of this is then just doing this to key state. Okay, I'm gonna have a whole bunch of type errors until I get this fixed. Oh, sorry, not that. This all to key state. So now when we detect the SDL event, right, we can combine it with our thing. So we'd have some way of going like key states. Maybe like SDL key state would be a good name for the function. This would take the list of SDL event, the key SDL key code that we want to check, and we get back a key state. Yeah, I think that seems reasonable. It would become and then we got to move this code up into, or at least generically, a generic way of moving this code up into STL key state. Presumably we'd be able to do our button state code the kind of what we want, replacing get key press with SDL key state of SDL.key code Q. This would have to return not a key state, this would have to return a button state. So we'd need the buttons. So what I'm thinking now, right now, like we have to pass in the button state, and we have to thread that all the way through for each of these things. Yeah, so this whole thing with the key state thing only gets me a piece of the puzzle. Button state's the next part of the puzzle, I guess. Let's do it this way, a button state like this. Let's just fill this in and see what happens. Alright, we essentially get We have a list of events, a key code we want to check, and we got to get a new button state. Or we have a button state as input. We have no way of knowing which field in the button state record we attempt to change here. And that, like, we don't know enough information about what to do here with this function, so this doesn't seem right. Yeah, I'm gonna have to give that a little more thought, and I'm gonna back out of that for now. Well, the key state stuff's kind of neat. I might leave that in and just refactor this part. So instead of checking the Boolean not, we have to do... We're gonna have is key pressed. The bool. Let's probably just write it this way. No. Yeah, let's just do it right this way. Whatever. Bam. Bam. Or, sorry, key down. Key up. Key release. Going to be more consistent. Otherwise, false. Nothing special there, but just a couple of functions to transform them back into bools. So if we have W pressed and key up, or key release, and the up button state is pressed. Key down. Key down. But if W up, the key up event is detected, and key down, the button state up is down. It's pressed, then we have key release. Otherwise, we have the same state. Cool. So we can replace not Key release. True. With key down. And then we have to put key down here and wrap you in parentheses and turn you into key release. Okay, let's go fix our other type errors. So update. So now button state left isn't a Boolean anymore. So we have to check key down. That takes care of all of those. And we should still have should still have the same behavior as before. And we do. Okay, leaving us room, leaving us enough affordance to refactor that further a little later. Once we figure out how to thread the button state through all these functions that test the SDL key state stuff. Okay, so I'll go check that in. Add key state to button state. Okay, next, let's start working on the thrust and getting the ship moving. Hey, Kodak Troll, welcome to the stream. No, I'm not using Monomer for this game. I am using SDL2 directly this time. We're trying to build an arcade game, an Asteroids clone, and but Monomer does use SDL2 under the hood, as we well know from our other game project. Cool. So, yeah, let's get acceleration and velocity and stuff working for our little ship here. Okay, so first let's look at the game state for the player variables. We have acceleration, max acceleration, that's good. Thrust, max and thrust speed, with thrust, rotation, rotation speed. So when we're applying force to an object in space, but in our simulation, right, we're going to apply force to the ship in the terms, in the thrust variable, right? This is how much thrust is available on the ship at a given frame. Thrust speed is how fast the thrust value increases per each frame. And max is the limit on the maximum amount of thrust we can have overall frames. We have an acceleration and a max acceleration. We have to add a couple of variables here. Or maybe change the variables, yeah. We're gonna change acceleration from a float to a vector. We're gonna keep the acceleration on both axes independent of each other. but we'll calculate them together. And this is so like with the rotation and stuff, we can figure out the calculation for how to move the ship, the position along the line using our acceleration. And I think that's all we need so far. So we'll change that to V2 float. I'm not using it anywhere yet, so we're not going to get any type errors in the file. Let's go to our update loop where we update the physics. Okay, so we change turn amount, we change thrust. We have to calculate the acceleration amount, acceleration vector. So let's do that now. It's a pretty simple calculation. So when thrust is applied, this frame, we're going to continue increasing the acceleration along the vector, along the direction that the ship is pointing. Otherwise, we ease off and we leave the acceleration. All right, so we check. We basically check if the button stayed up, the game state, button state is pressed. Okay, now we have the two parts to update, the X vector and the Y for acceleration. V2, we can construct that with the V2 constructor. We have to give two values, and then we get a new value back for acceleration, which we can pass here. Layer acceleration. Okay, so let's pull that over here. Okay, so our X and our Y will colloquially refer to the first part of our vector as the X part and the Y part. The formula for X will be the game state acceleration. Well, the first part of it. How do I get the... How do I get the parts out? Haskell, yeah, linear. I have to pull apart. To pattern match them out. Okay. Fine. Make me. Okay, so we need AX to be something. AXAY, like this. Game state, player acceleration. With V2, right? That's, yeah, just like that. So then this formula becomes ax plus the current thrust that we calculated up here times the cosine of the rotation. And this becomes ay plus thrusts times the sine of the game state's player rotation. We have to have an otherwise case. We'll just leave acceleration alone, I think is what we said. Otherwise equals game, state, player, acceleration. Yeah, okay. And then the next part of this is the next state calculation. Let's see. Updating the position of the velocity. That's right. Oh, that's the variable I'm missing. Velocity vector. So your velocity vector is like the direction of travel in your spaceship, right? Like you've probably seen it in like space shows where, you know, they're flying a spaceship and they're going across the screen and like they turn their ship like this, but they keep going. And that's their direction vector where they're heading. Because the thrust got applied behind the ship and all like that. So we'll keep track of that as well as a vector. Game state, player velocity. The default one. And, oh, player acceleration, we have to change that as well. Okay, so then our next state for our vector. This becomes the acceleration times the delta time. So the delta time change between each frame. Game state accumulator, game state player vector, player velocity, sorry. And we need to add that to the acceleration times delta time. We should have the delta time, the update, right? Yeah, stored in the game state. Fix renderer, accumulator. No, we needed the... Oh, I might be missing the delta time. What was fixer time step? Good old gap around games. So when you integrate, you have to pass the delta dt here. Oh, our delta time's a constant, right? Okay, so that's pretty simple. Okay, so we're gonna need some linear functions. All right, we can add two vectors together. Let's call it player vector to get rid of the shouting thing. But we need to multiply it by a scalar. Function for that. Go to... There we go. Yeah. So we need that from linear.vector. It'll look like this. DT needs to be a float, or a delta. Okay. We have as a double. We might need to fix that quickly. Delta. So this, our accumulator and ticks, probably doubles as well. Probably no harm changing those to floats. Go. Okay, yeah, so then we get the scalar multiplication, and that's how you do that. Awesome. So game state, player vector becomes the player vector, the next one. Velocity, sorry. That's why we can change this to velocity. That's more clear. Good. Then we need to change the position based on the velocity. say here, game state player position. We add to that the game state player velocity. And we do another scalar multiplication with delta. That. This is going to be a tight mismatch. Things are positioned currently is stored as a cint. And it's stored as a cint. Why is it stored as a cint? It's stored as a cint, I think maybe because of the rendering code. Render player ship. Yeah. So the render player ship gets these list of points that need to be given as cint to the rendering library in SDL. So I'm thinking is that we store it in our game state as a float, and we convert and truncate to cints when we go to render. We'll possibly get like a bit of inaccuracy, but I mean you have to anyway at some level. And as long as we do consistently, it should look fine. So let's go do that refactor too. So we get a different type error in a different area down here. But the rest of our code here should be fine for updating all that stuff. Acceleration, I think that has to go back down to 0 at the end of the frame. Or we have to clamp it. Let's try clamping. I think that's the only thing that's missing here. Game state player acceleration, max acceleration. Yeah. And the same here. Super. Okay, so then we got to fix our rendering code so that we can do all this stuff. So the player ship, we need not a cint, we need a float, which annoys this code here. Rotate origin. We could convert here. from interval 2 integral. Truncate, we gotta truncate from today's part at this point. Positions, yeah, position's still a V2, so can we... Does that make sense? GC seems to think so. Then we have to use game state player position. Position. Okay. So compiles. Not saying it's gonna work. I'm only like 75% sure. So let's get focus. We can rotate. Okay, we're not moving anywhere when I'm pressing my thrust button here. Okay, so let's see, player velocity, that's the delta. Velocity is acceleration times delta. Change the acceleration key down. The up button's pressed. See, we use acceleration x part of the acceleration vector. So we add the old value plus thrust times the cosine of the current player's rotation clamped to the max acceleration. We use all of those. Okay, we're gonna need some debugging. Import debug.trace. Let's debug. Okay, so I'm gonna put my trace up here after the update loop on the game state. We integrate all that physics together before we render. Player position. Show game state player position of state prime. Unit. Oh, do I have record wildcards open here? I do. Okay. That's kind of an annoying thing I find with record wildcards. That currently this is like a value, not the function, and I want the function. How to solve this? Can I qualify that name with the current module's name, maybe? I don't know. Seems to. Cool. So it's not changing. The position value isn't changing at all. Okay. Leave that there. I'm gonna check the thrust. Make sure that's still working. Thrust at 3 down. Yeah, so thrust is still working. That's good. Pure code. Okay, that's fine. I can stick this. So in pure code, you can't quite do that trick. We're not in a do block, but we can do it like this. Okay, no matter what I do, position isn't being recalculated. Yeah, oh yeah, velocity's right, yeah. That's the old velocity, right? Yeah, that's fine. And this velocity... Did I delete velocity? I deleted velocity. Velocity... yeah. It's the old velocity plus the acceleration times the delta. Let's see if the velocity is being changed. So it needs to show that. Velocity isn't being recalculated at all either. I'm really holding that button there for a while there, trying to get some data. Velocity is always staying at 0, never changing. Okay. So thrust is working. Acceleration, position, and velocity are not. Oh wait, we didn't test acceleration, it's just acceleration. Okay, so acceleration is changing. Like we see it, hopefully you can, it's scrolling by really fast, but if I quit it and look at the inputs, like it is changing. Interesting the values it's getting. Yeah, it's definitely less than 3. Okay, so it's coming out as negatives. Yeah, well, maybe we need to set the acceleration back down to 0 when we return. No, that doesn't make sense. Okay. So that doesn't use acceleration. So velocity should be changing based on the acceleration. Oh, delta time is 0. That would probably do it. Except I completely bored something here. Interesting. What did I break? Huh. So I think what's happening is that we're doing the multiplication with that delta, but the delta is 0, so it's just zeroing out everything else. Since the acceleration isn't doing that, it's happily chugging along there and changing. But everything else is getting zeroed out. If I change the delta, which delta shouldn't have been 0, so I probably made a mistake there with that. But when I change it to 0.1, then we get some lockup. So what's happening with our loop? Whole events process input. We get a new button state. Calculate the frame time based off of our last frame time and the new time. And then we run the inner state loop. Asking new time as the current time. The accumulated time as the game state accumulator plus the frame time. So our last accumulator value plus this amount of time we're going to spend on this frame. An update will keep running. So if game state accumulator is greater than delta or equal to it, then we do next state, return the next state. Otherwise, and on the first iteration, this should be true. Right, game state accumulator should be greater than 0.1. Otherwise, we update with next state. And when we update next state, we decrement game state accumulator by delta. So our fixed amount would be 0.1, say. This should eventually be true in return. No, this will always be true. Right? Maybe we got the sign wrong. So we should be, once the accumulator runs out of time, that's when we should return. Fixing a whole bunch of things at once here in flight. This is when things go weird and wonky. Okay, that's better though. Oh, we got movement though. There we go. Not on the right vector, but... yeah, that went the completely wrong direction. Okay, so there's movement. There's movement in this case. So that problem's fixed. We got that wrong. Wow. Okay. That's a lot of stuff. one change. But we're still kind of working on movement here, so let's try and get that fixed. Get rid of the debug statements here. Scare. Okay, so what's happening here with our vector, velocity vector, and where we're going? So when we press thrust up right now, visually, the nose of the ship is at the top of the screen, and when you press W from here, it should go up. But it's going to the right. Pretty much at exactly 90 degrees from where we want it to go. Never minding the acceleration is going crazy, but that's fine. Problem with that, what the problem with that is, what do we set our default value for rotation? 0. So we're kind of drawing, well, we think that 0 means like the top of the circle, and that the rotation is going to happen around the outside of it like this. But it looks like in reality, it's on this side of the circle, and how we're changing that value is affecting things. So we need to like figure out our unit here, right? It should be probably radians. And so what we're rendering might not be reflective of like where this thing is pointing. If I change my rotation, my initial rotation to if we say this is 90, like it's degrees. It's not. Or at least it doesn't look like it is. Right? It's kind of turned around, that if I press W, it's going to go off in a completely different direction now. That way. It's almost as if where we think the ship is pointing, where we think the vector is pointing is not. So ship points. Should we commit? We should probably create a commit here. I feel like this is starting to get a little risky. If I go like this, yeah, the movement kind of works. We got to clamp the acceleration there a little more. Or set it back to 0. we don't need a max. That's a little better. Still not pointing the right way, but if we imagine our ship, we just have to fix the rendering of the ship, but... And then we have to get the toroidal surface working. But otherwise, we apply a little force, and it moves. A little force in the other direction, and it moves. And we go. And there we go. Woo. Okay, so I'm going to commit that. Add ship movement. So thrust is now applied. The ship accelerates along a velocity. Yeah. Good message. All right. So let's fix the ship rendering. Okay, so if our rotation at 0 is actually like going to the right, so to speak, we just have to fix our offsets for these positions. And then like the rotate origin function should still work around that. Bring that over to the left a little bit, just to make it a little more readable. So the first point, we're taking the ship's position, and we're not changing the X, we're just going negative size, we're going up the screen. So we actually need to change the X, we need to flip that around, and go to the right. So we need to flip that like that, and that's this way. So this position, now we need to not change the X, and so I think these points went top. This was, yeah, size divided by 2, so it was on the X. That one. So it went this way. And size in Y, so it went twice. So it went down this way. But now, we need to go negative X. Flip this side. And you go negative X here as well. And flip this side. then this final one goes back up to that one, so we have to draw it in a path. So we went that way, out the right side of it, we went up. The next one, we went this way. So now we need to go back along X. Let's see, something like that. Might be a little off, but we can always fix it. Not quite. Pointing in the right direction, but this last line is just not pointing in the right place. Near. Ooh, okay. We're just gonna remove the sign on it. There we go. Woohoo! Now we got our ship moving around. You give it thrust and it kind of goes. And it feels kind of like a ship. Pretty good. Okay, unfortunately we are out of time, but we got ship movement going, so hooray! Alright. If you're just joining us for the first time, I do these streams once a week on Tuesday evenings, where we explore functional programming in Haskell, for the most part. Sometimes I do other languages, and we do other side projects and fun stuff every now and again, but the regular streams on Tuesday nights. The best way, of course, to follow along is to follow here on Twitch, and you'll get notifications when I go live. And otherwise, if you're watching on YouTube, you know what to do there as well. You can catch the videos there when I post new ones from these streams, and you can follow me on. You can follow the code for this project on GitHub. I am Agent Ultra, pretty much everywhere, for the most part. Can't guarantee that. And this is under Asteroids, which is this Asteroids clone that we're building here in Haskell to test out. Is Haskell a great language for building arcade style feeling games? So we have a little bit of ways to go. Now that we've got ship movement going, we're gonna get next week we'll get the toroidal map working so that the ship can go, when you go over the top, it comes back around, loops back around. We're going to get the blasters going, we got to get the asteroids themselves moving and interacting with the blaster and all that sort of stuff. So a couple more sessions ahead and we'll have like a little solid game going. And then we'll figure it out. We'll see, and we'll do a little retrospective. So yeah, so you can get the code here. Org it, watch it, whatever you want. There you go. May all your monads be free. May your types always check. And hopefully I'll see you next week. Take it easy.